Hello everyone. So today we will look at the low power modes of operation in MSP 430. So altogether there are 5 low power modes, that is starting from LPM 0 to LPM 4. 0, 1, 2, 3, 4. But 2 of them, that is LPM 1 and LPM 2, are very rarely used. So we will be discussing LPM 0, LPM 3 and LPM 4. Now beyond that, we have the active mode, which is not a low power mode, but when we are considering the modes of operation, we have to mention the active mode as well. Okay, so we will start. Now before that, how do we get to a low power mode? How do we reduce our power consumption? So basically we can have 2 different ways. First way, we can reduce the clock frequency. Okay, so we know that in your MSP 430, we have 3 different clocks. What are the 3 different clocks? We have the MCLK, we have the SMCLK, and we have the ACLK. We'll just look at that block diagram once. Yeah, so this was the basic clock system. We have the ACLK. ACLK operates at the least frequency, that is approximately in kilohertz. It's in 32, minimum of 32 kilohertz. Then we have the SMCLK, that's the subsystem master clock, which can run at the same frequency as MCLK, that is 16 megahertz, it's a maximum, and lesser. And we have the MCLK. So the MCLK is the clock which supplies to the CPU and a few peripheral devices. Now every clock behind it has a oscillator. So the clock generating system is basically based on oscillators. So oscillators also, we know we have the DCU, that's the digitally controlled oscillator. We can have crystal, okay, and we can have, so LFXT1 is a low frequency crystal 1, and we can have the VLO, very low frequency oscillators. Okay, so here now how do we reduce the frequency? So MCLK, we know it is at 16 megahertz. So suppose we do not want the operation of the CPU, we only want the peripheral device to run. For example, we'll take the case of the timer A. We know timer A. We want the timer A to run, and we have set a particular time. Once that time is over, an interrupt will be created and it will do a particular function like we had done for, let's say, blinking an LED. So when this LED is blinking, suppose there's no other functionality to be done, we can switch off the CPU. And in that case, we do not require the MCLK. The system can run on SMCLK. So the frequency can be reduced, that power consumption also can be reduced. That's one way. So by underclocking or downclocking, we can reduce the power consumption. That's a technical term. It's called downclocking or underclocking. Second way to reduce is by reducing the operating voltage. We know that it operates at maximum of 5 volts. Now there are different voltage thresholds that we have learned. We have learned about a 3.3 volts. That is the maximum operating frequency of 16 megahertz can be obtained only if there is a minimum of 3.3 volts. Okay, if the device is operating at 3.3 volts. Another threshold that we learned was 2.2 volts. That is, if you have to program the flash, then VCC should be at least 2.2 volt. And the least threshold is 1.8 volt. If it reduces beyond 1.8 volt, the brownout protection comes into action. Okay, so 1.8 will be the least threshold. So here in the low power modes, we will be reducing the clock frequencies. That is, we will be switching from one clock to the other to reduce the power consumption. Okay. So now coming back, how do we now switch off the clocks? So we have learned in the status register, when we learned the status register, 4 bits were related to the low power modes. That is SCG0, that's the system clock generator 0, SCG1, OSC off, that is the oscillator off, and CPU off. Okay. So again, another thing that we had learned was when you go to interrupts, that is when an interrupt comes and you go into the interrupt service routine. Okay. Which mode are we in? We